My name is Jonathan Light, and welcome to our latest podcast on foundation models and decision making. Today, I'll be presenting this paper called Strategist, Learning Strategic Skills by Large Language Models via Bilevel Tree Search. This is the website for this paper, which you can find at this address. So in this paper, we're interested in exploring how large language models, how we can use large language models to play these social deduction games, right? Example of a social deduction game is Resistance Avalon, which I have a picture here, right? And in these social deduction games, each player has like a hidden identity, and they don't know the identities of the other players. And in the game, through discussion, they're trying to figure out who's on their side and who's on the enemy side. And there's a lot of interaction, lots of deception, deduction, and deception in the game, which really challenges the agent's skills at both language and also at reasoning and planning, right? They also take actions in the game, so there's also like a big planning component here, where they're trying to figure out what's the best action, right? So what's really cool about these game settings is that you can actually see how the agent performs, and you can actually interact with the agent. So I'm going to show like a quick demo right here. First I'm going to show a demo of a game where it is purely action based. This is a game called GOPS, Game of Pure Strategy. In this game, there is a prize deck, and each player also has a hand. Each time a card in the prize deck is revealed, and the players, there's two players, and player one and player 0 both have to both reveal a card simultaneously from their hand, and whoever has the highest card wins the prize card, right? So for example, here I am player 1, and player 0 is actually a large language model powered enhanced bot, right? So we can actually play against this bot here. These are the cards in my hand, cards 1 to 6. For example, I could play card 3, right? And then we see here that that I played card 3. My opponent has played card 1, so I got the prize card, which was a 4. We can also play a game of Avalon, right? So here I'm prompted to speak. I am player 0, and all the other players are large language model agents, right? So I can say, howdy, I am super happy to be here. It looks like the LLM agents have finished thinking and they've spoken. So for example, here's some dialogue from player 1. Right, hello everyone, it's great part about this quest. I certainly true that we're out in the dark, blah blah. You can see it's quite, dialogue is actually quite nuanced, right? And it's definitely, it sounds like something like a human would say, right? For example, like player 2 says, "Oh, I appreciate player 4's balanced approach, involving variety of players in this quest," right? Right, I respect player 3's suggestion having player 2, blah blah. So it provides some reasoning behind its judgment and provides suggestions, right? That tries to advance its goals through these suggestions. So I'm taking action here. This is like vote 0 1. So maybe I vote for pass, right? And now we begin another round of discussion. So yeah, it's pretty cool. Be sure to check out our website and our paper for more details and updates, right? We'll be releasing an interactive demo of the agents you just saw soon, so you'll be able to interact with the agents on the website. We include more details on how we actually improve the agent, right? In our paper and on the website. Here's a pseudocode. Here's like a diagram of how the process works, right? This is an improvement process where the agent receives feedback from self-paced simulations, and it uses that to improve itself with the help of a large language models. We also show some results, right, of how it performs against both other improvement methods and also against reinforcement learning techniques traditionally used to train such agents in games. So yeah, cool stuff. And thank you for listening.